Right, so we're going to finish looking at solving systems of equations. And today we're going to look at solving systems using a matrix. How many people have used matrices specifically for systems? A couple? Was it in discrete? Were you both in discrete last year? Okay.
Julie always too.
Yeah, Julie. So if you had discrete, you probably definitely would have looked at this. The idea of using a matrix is those two reasons. One, it allows us to write down a lot less information. We don't have to write any variables. And two, it takes out all of the, or most of the guessing. Like, should I pick equations 1 and 3 and solve for x? Or should I pick 1 and 2 and try to solve for y? Or what should I do? There's lots of combinations. This is going to eliminate a lot of those choices. Okay? So it's much more structured. So this would have been a review. I'm not going to go through doing it again like we already did, because we just did one in the homework. I will do that problem, but I'm going to do it as a matrix. Okay, so what is a matrix? Well, it's just a table. That's all it is. Okay, it has rows and it has columns. If you do anything with programming and you've heard of arrays, that's what it is. It's an array, two-dimensional array, rows and columns. And it's just an organized way to represent everything, where the number of rows and the number of columns are used to describe the size of the matrix. So if you had something that looked like this, we would say that has 2 rows, 3 columns. This is a 2 by 3 matrix. That's the dimensions. So in this case, M is 2. That just stands for the number of rows. And N is 3. That stands for the number of columns. If the number of rows and columns is the same, then that kind of matrix has a special name. It's called a square matrix. And that's because when the number of rows and columns are the same, the layout looks like a square. Three rows, 3 columns. This is a square matrix. So square has nothing to do with the numbers in it. It has to do with the fact that the number of rows and columns are the same. Put whatever you want in the matrix. If you are referring to a specific number within the matrix, that is called an element. For example, if I said to you, what is the element in the 3rd row, 2nd column? You would say 8. 8 is the element that's in the 3rd row, 2nd column. So an element is like a specific spot in a matrix. And we have a notation we use if we want to describe a particular location in a matrix. And the way we do it is, first of all, a matrix is generally named with a capital English letter. So this matrix is called matrix A. If I want to refer to a particular element within the matrix, the notation our book uses is the lowercase version of the name. And then it has these little subscripts, 2, 3. The 2 is the row, and the 3 is the column. So this is asking you in matrix A, what's in row 2, column 3? And in that case, row 2, column 3, it is a 9. Now, one thing we do a little bit different than you would if you were doing programming is when we start counting rows and columns, we start with the number 1. 1st row, 2nd row, 3rd row. When you are programming, you generally do not. You start with row 0. Row 0, row 1, row 2. All right. Starting with 0, can be a little confusing sometimes because then you kind of can forget, oh yeah, I had row 0. So we don't do it that way. We start with 1, 2, and then 3. Any questions on the notation that you use to find a particular element? Okay. So there's lots of different things you can do with a matrix. Again, a matrix by itself doesn't do anything. It's just a way to organize a bunch of numbers. Now it's what do you do with that matrix? Well, we're going to solve systems. And the advantage to using a matrix to solve a system is you don't need to write down any letters. So all the work that we're going to do, we are not going to be writing down letters. We're only going to be writing down the numbers, specifically the coefficients of the variables. And just remind me again, what does coefficient mean? It's the
number next to the letter.
Right, the number that's in front of the letter. So that's what's going to be important. The numbers in front of the letters and the numbers on the other side of the equal sign. We're going to need those too. And the way we're going to organize it, so we don't have to write letters, is each column in the matrix is going to represent a particular variable. So for example, if we have this, and I wanted to change just the left-hand side to a matrix, I would do 2, -5, 3, -8. The first column in this matrix, right here, this represents my x's, the numbers that were in front of x. The next column is going to represent the numbers that were in front of y. That's how we always do it. Okay, our columns are always going to represent, in alphabetical order, x, then y, and if we're doing 3 variables, z. What I just made, right here, that I just circled in green, or I guess blue, that is called the coefficient matrix. It's a matrix that contains all the numbers that were in front of variables. But the coefficient matrix doesn't have everything in it that this original problem had. What's the coefficient matrix missing?
The answers. Or what's on the other side of the equal sign?
It's missing what's on the other side of the equal sign. So what we're going to do is we're going to add on a column. On the right-hand side, we're going to add a column or augment the matrix with a column that represents the constants. So in this case, 4 and 7. That would be the full matrix that we would use to solve this problem. 2, 3, 4 in the first row, -5, -8, 7 in the second row. So first you build the coefficient matrix, and then on the right, you're going to add a column for the numbers on the right side of the equal sign. When you create the matrix, it's very important that you are setting up your x's in one column, then your y's, then your z's. If I give you a problem where the letters are not lined up, you need to fix that first. They've got to be lined up. Okay, so any questions on how I turned those two equations into that matrix? Just turning it into a matrix, that doesn't solve the problem. It gives us a shorter way to represent the problem. But now I need to show you what do we have to do with this matrix. It's something we have to do to it. Okay. And the goal is going to be to turn our matrix into what's called row echelon form. So what does that look like? Row echelon form is when you have a matrix with ones on the diagonal and zeros everywhere below it. So for a 3 by 3 matrix, it would look something like this. Anything that's not a 0 or a 1, I'm just making up the number. A lot of times what I do is to separate the numbers that are on the other side of the equal sign, I'll put a vertical line right there. That vertical line tells you that's where the equal sign would be. So if I wanted to do that in this problem, put a vertical line right there. Yeah.
The one with the ones and the zeros is an identity matrix, right?
If you have all ones and zeros, that's called an identity matrix. Yep.
Would that be the same as saying row echelon form or no?
So row echelon form is only when you have zeros below, but you can have anything you want above.
Okay.
If we did what's called reduced row echelon form, then that would mean to turn this into the identity matrix.
Okay.
Yep. But we're not going to quite go that far.
Okay.
So what's in these spots? I don't really care. Whatever happens, happens. All that I care about is that we get ones on the main diagonal and zeros everywhere underneath it. And to do that, you have to follow a certain order. I'm going to show you the order of things that you have to do. So overall, there's 1, 2, 3, 4, 5, 6 elements that you need to make correct. The first one that you have to do is that one. We have to get a 1 in the upper left. The second thing we have to do is get a 0 underneath it. And the third thing we have to do is get a 0 underneath that. So you have to work with it a column at a time. If you don't, what can happen is you might get something the way you want it, and then you do a step and it messes up what you just did before. We don't want to do that. We got to do it in a very organized way. So once we make something a 1 or a 0, we never mess it up again. Okay. The fourth thing that you're going to do is get a 1 right in the middle. The fifth thing you'll do is get a 0 in the middle of the bottom row. And the very last thing that you'll do is get a 1 in the lower right. That's the order we need to follow. Okay, well, that's our goal. Now, how we get 1s and 0s in those spots, I need to show you what you are allowed to do. There are 3 things that you're allowed to do to a matrix, and it will not mess up your answers if you do them right. The 3 things that you are allowed to do are called elementary row operations. They are things you can do to a matrix that effectively doesn't mess it up. Okay? The first thing that you are allowed to do is you can take any 2 rows and swap them. Swapping 2 rows does not fundamentally change anything about the matrix in terms of solving it. You cannot swap columns. Definitely not. But you can swap rows. The next thing you are allowed to do is you are allowed to multiply a row by a constant that's not 0. Yesterday we called this a linear combination. So you can multiply a row by any number that's not 0. But you have to do it to the whole row, not just part of the row. And the third thing you're allowed to do is kind of like an extension of the second rule. You can multiply a row by a constant, and then you can add that to another row. We did a lot of this when we were solving systems yesterday. We tried to make things cancel out. So I told you to make something cancel out. You needed to have a number and the opposite of that number. And that's going to be the goal today. We want to try to get like a 3x and a negative 3x so they cancel out and become a 0. But those are the only 3 things you're allowed to do. Now, just in terms of being clear about the notation that I'm going to use, when I write a number and I circle it, that means it's an equation. Okay? So any number that is circled, that means equation 1. That's equation 2. If I write a number and I don't circle it, it's just a number, like the number 2. Anything circled will represent an equation. So that's the first thing I'll always do. I will number my equations so you know which one is which. Okay. Any questions on what I mean by those 3 things? All right, so let's look at an example. So we're not really solving this one again. We're doing it for the first time. And I'm going to use a matrix. So as we're writing it down, we want to think back to this diagram and think of the very first element that I'm going to focus on. What's the first element that I'm going to try to work with in that matrix? It's in what row and what column? Row 1, column 1. That is the first thing that you want to work with. And the goal is to turn that into a what? You want to turn it into a 1. If I write down my matrix just the way it is here, what would the number in the upper left be?
0.
It would be a 0. That's not what I want. Is there anything that I could do that would be simple and result in having a 1 in the upper left?
Flip row 1 and row 2.
Yeah,
Yeah, row 1.
let's swap rows 1 and 2. Okay. So the way that I write swap is like this. That means swap. Take rows 1 and 2 and switch them. So now, if I do that, in row 1, I'll have 1, negative 2, negative 3, 0. 1, negative 2, negative 3, 0. What would be my numbers in row 2?
0, 2, 1, negative 8.
0, 2, 1, negative 8. And in row 3, nothing happened. There's a lot of copying in this process. So you really want to be careful you copy correctly. Negative 1, 1, 2, 3. So if you notice I make a mistake, just let me know. Okay, so now we got a 1 in the upper left. That's the first step. Second step. What element do I want to focus on for the next step?
Getting a 0 in row 1, column 2.
Getting a 0 in row 1, column,
Oh, column 1, row 2.
yeah, column 1, row 2.
Which we already have.
I already have. So this time I can skip that
Row
step.
3, column 1.
So now I want to focus on getting a 0 in row 3, column 1. Do I have a 0 in this spot right here? No, then I need to make it a 0. The way I'm going to make it a 0 is I'm going to do something with row 1. Maybe I have to multiply it by a number, who knows. And then I'm going to add it to row 3. Would I need to multiply row 1 by anything to make this and this opposites? That's the goal. No, they're already opposites. So what I want to do now is, next step, take row 1 and we're going to add it to row 3. Now, if that's all you do, you haven't put the answer anywhere. Okay, this is just like something we're going to do in our head. We're going to add row 1 to row 3. and we're going to store that answer in row 3. So row 3 is going to be replaced. It's going to be replaced by adding rows 1 and 3 together. So nothing is happening to row 1, nothing's happening to row 2. We're not storing anything in rows 1 or 2. So we can copy those down. 1, -2, -3, 0, 2, 1, -8. And now follow what it says to do. Bless you.
Thank you.
Add rows 1 and 3 together and replace row 3. What's 1 plus -1?
Did you copy the wrong row?
0, 2, 1, -8, 1, -2, -3, 0. Nope, everything looks good.
We haven't put in row 3 yet, because that's, we're doing the addition first, and then we're
Yeah.
going to add row 3.
Okay.
So let's add row 1 and 3 together and then put the answer as the new row 3. What's 1 plus -1? 0, and that goes in the new row 3. What's -2 plus 1?
1.
-1, and the answer goes in row 3. What's -3 plus 2? -1. And what's 0 plus 3? 3. There we go. So that's my new matrix, and the first column is done. That first column should not change for the rest of the problem. If it does, then you mess something up. Okay, but it should not change from 1, 0, 0. Okay, what's the next element that I'm going to focus on?
Row 2, column 2.
Row 2, column 2. What do I want that to be?
1.
I want it to be a 1. Now I can't swap it with anything to make it a 1. So I'm going to have to do something different. Yeah?
Multiply by 1/2.
Multiply by 1/2. Yeah. So we're going to take row 2. So I'm going to circle the 2, row 2. We're going to multiply it by 1/2. And that's going to replace what?
Row 2.
Row 2. So that's my next step. What's not changing in this step? Which rows?
1 and 3.
1 and 3 are not. So what I like to do is copy down everything that doesn't change first. 1, -2, -3, 0, 0, -1, -1, 3. Now, take half of everything in row 2, and that's your new row 2. What's half of 0?
0.
0. What's half of 2?
1.
1. That's not too bad, but it's not great. What's half of 1?
Half.
Half. So now we got a fraction we have to deal with. But that's not bad. And what's half of -8?
-4.
-4. Okay, so now that's good. Okay. Next step. What element do we want to focus on now?
Column 2, row 3.
Row what?
3.
Yep.
Column 2.
Column 2. Focus on that. And what do we want to turn that into?
0.
We want to turn that into a 0. To do it, I need to use something above it. Don't use the top row, because if you do that, you're going to mess up your 0. You have to use the row immediately above. So what could I do to create a 0 in that spot?
Add row 2 and row 3 and replace it for row 3.
Yep. So take row 2 and row 3, add them up, and that will replace what's in row 3. So which rows are not changing?
1.
1 and 2. In fact, 1 and 2 are done for the rest of this problem. So 1, -2, -3, 0, 0, 1, 1/2, -4. And now add row 2 and 3 together. What's 0 plus 0?
0.
0.
0. What's 1 plus -1?
0.
0. What's 1/2 plus -1?
-1/2.
-1/2. And what's -4 plus 3? -1. All right, so we've got the 1, we've got the 0, we've got the 0. We've got the 1, we've got the 0. The only thing we don't have is a 1 right there. And we can skip that because think about what this equation says now. We changed it originally from the letters to just numbers. I want you to change this row back to numbers. What does that bottom row say now?
Negative 0.5 equals -1.
Can you do the whole thing for me, even the zeros?
0x.
So no x's
0y
plus no y's.
minus 0.5z equals -1.
Yeah. So that bottom row says no x plus no y minus a half z equals -1. That's the step where we get to, and now we can get our first answer. How would you get z by itself?
Divide by negative 0.5.
Yeah. Divide by negative 0.5,
Z equals positive 2.
and z equals 2. Yep. Now, from here, we use substitution. You're going to substitute that back into your other equations to solve for y, and then you'll solve for x. All right, so you want to plug this back into an equation that has a 0 in it for x. Well, we have 2 of those. Either one of those equations will be fine. Do we want to use the top one or the bottom one? Top one. That says, well, actually, you tell me. What does that top equation say?
It says 0x plus 2y plus 1z equals -8.
Yeah. And now that we know the 0, it just means it's not there. We don't have to put that anymore. So 2y plus z equals -8. 2y plus z equals -8. And what did we just get for z? 2. So fill that in right there. 2y plus 2 equals -8. So we get 2y equals -10, which means y equals
Negative 5.
-5. Okay. Now we got 2 letters. We can go back to the original and pick any one that we want. Well, you can't pick the first one because that doesn't have an x. But do we want to use the second or the third one?
Third.
Second.
Well, yeah, you could use either one. If you use the third one, you got to deal with this -1. If you use the second one, you don't have to deal with the negative.
Well, we have to use something like the third equation on the past.
Potentially.
So could you do that one out just so we can see it?
The third one, yeah, it's an extra step. We can. I wouldn't choose to do the third one personally, but yeah, it's good to look at, I guess. So negative x plus y plus 2z. Is that equal to? Negative x plus y plus equals 3. Okay. We don't know x, but we know y is -5. Z, we're going to fill that in. 2 times 2 gives me
4.
4. -5 plus 4 is
-1.
-1. Add the 1, that's going to give you 4, which means now this is the extra step. You just got to change the sign. And x is -4. There you go. So using a matrix, it is just less writing. It takes a little bit to get used to the steps, but it's less writing than having to put the x, the y's, the z's, and all the equal signs. Yeah.
The last part of the lower one, I just used the equations in the last matrix.
Yeah, so there's different ways you can solve it, yeah.
The answer, just put in the next one up and then got the answers.
Yeah. So when you substitute back in, you can pick different equations.
Yeah.
Bottom part, that's what I'll do.
Got the same answers.
As long as you get the same answers.
Okay, but that's pretty much, that's all your work to solve that problem.
I don't have solver Rubik's Cube.
Any question on the steps. These are the main matrix steps right here. There were 4 of them.
Can I take a picture of the board?
A picture? Sure.
Can you, so can you plug back the any letter in any of those 4 questions? Any of those 4 matrices, whatever?
So yeah, there are options. Generally, the order you get is Z, Y, X. You generally have to follow that order. But you can plug into different equations to get the same answers. Yeah. Okay. So let's try this one. And we'll try to solve it. This one, I just want to set it up because you are going to have something similar. We're not going to solve it. And that'll be the last one. So the word problem, I think that can be the trickiest because you've got to set up your own equations.
Okay.
So as we write this down, what is our first goal when we're trying to set up our matrix? We're trying to get a what number in what spot?
1 in row 1, column 1.
A 1 in row 1, column 1. Do we already have that?
Yes.
Perfect. Then let's copy that down just the way it is. We're not going to do any swap. 1, 1, 1, 6, 1, -1, 5, 16, and 3, 1, 1, 16. Okay, so we're good with the 1 in the upper left. What's the next goal? We're actually going to do this and the next one at the same time.
Get a 0 below the 1.
We want to get a 0 right there. And what else?
A 0 below that.
Yes.
And next to it on the right side.
So just zeros in those 2 spots. That's it.
No, there's also 1 and the 1 next to the 3. Or are you just talking for right now?
Yeah, all you can deal with is 1 column at a time.
Yeah.
Yeah. So the fact that you already have a 1 in this spot means nothing. You're going to have to mess that 1 up. It's over in the 3rd column. I don't care about the 3rd column till I get the 1st column. So we got to work left to right. Okay. So which row is done for this problem? It's not going to change at all.
1 column 1.
So which row?
Row 1.
Row 1's done. You're never changing row 1. So 1, 1, 1, 6. We're going to copy that down a lot. Okay. Next thing we want to do is get a 0 right here. Can you add row 1 and row 2 to make what's in that box a 0? No. So then you need to multiply row 1 by something first. What could you multiply row 1 by? You could multiply it by -1 and then add it to row 2. And that's going to replace what's currently in row 2. Okay, so we're going to do that step. You know what? I'll put the step above it because I think that's how I did it before. Now, let's look at it again. Can I add row 1 to row 3 to make a 0 in this box?
No.
No. So then I need a little bit more space because I have another step I need to write. What could I multiply row 1 by to make this a 0?
-3.
Yep. Multiply row 1 by -3 and then add it to row 3. And that's going to replace what's currently in.
Are you doing 2 steps at once?
Row 2.
We're already replacing what's in row 2. That's the top step.
Row 3.
We're replacing what's in row 3 now. So yeah, we're doing 2 steps at once. This is the only time we ever do 2 things. Everything else we always do 1 thing at a time. Okay. So let's start with the first one. Multiply the first row by -1. Add it to row 2. What's 1 times -1?
-1.
What's -1 plus 1?
0.
0. Okay. Do it again. What's 1 times -1?
-1.
Plus -1?
-2.
-2. What's 1 times negative 1?
-1.
Plus 5?
4.
4. What's 6 times negative 1?
-6.
Plus 16?
10.
10. So I multiplied everything by negative 1 and added it to row 2. Now, multiply everything by negative 3 and add it to row 3. What's 1 times negative 3?
-3.
Plus 3?
0.
0. 1 times negative 3?
-3.
Plus 1?
-2.
2. 1 times negative 3?
-3.
Plus 1.
-2.
Same thing. A lot of repetitive ones on this one. What's 6 times negative 3?
-15.
-18 plus 16.
-2.
-2. Okay, so actually there's a lot of nice things happening here. First column is done. That should no longer change. First row is done. So the only thing that should be changing now is what I just put a box around. You're done with that other part. Okay. What's our next goal?
To get a 1 where the -2 in the middle is.
The next goal is to get a 1 right there. And these are all even, which is actually, it's going to make it really nice. What do we, what could we multiply row 2 by to make that a 1?
Negative.
-1/2.
-1/2. So multiply row 2 by -1/2. And where are we going to place that answer?
Row 2.
In row 2. So which rows are not changing in this step?
1 and 3.
So let's copy those down. There's 1. There's 3. Okay, so multiply by -1/2 and put it back in the same row. What's 0 times -1/2?
0.
0. What's -2 times -1/2?
1.
1. What's 4 times -1/2?
2. -2.
-2. And what's 10 times -1/2? -5. Okay, we got a 1, we got a 0, we got a 0, we got a 1. So we're good. What's the next element that we focus on? And this is really going to be our last matrix operation
The -2 in the bottom, in the middle.
in the middle. And what do we want that to become?
0.
We want that to become a 0. Which rows don't I need to change anymore?
1 and 2.
1 and 2 are done. So 1, 1, 1, 6, 0, 1, -2, -5. Okay. You have to use the row that's immediately above it. You can't go back to row 1 anymore because you'll mess up this 0 if you do. Can I add row 2 to row 3 and make what's in that box a 0?
Not like it is.
No. Then I need to multiply first. What do I need to multiply row 2 by?
2.
2. So take row 3, you're going to double it and add it to row 3. I'm sorry, double row 2. Wrong number. We're going to double row 2 and add it to row 3. And where are we going to put that answer?
In row 3.
In row 3. Yep. Okay, so double and then add. If you double 0, what do you get?
0.
Plus 0.
0.
0. What if you double 1?
2.
2 plus -2.
0.
0. And if you double -2?
-4.
-4 plus -2.
-6.
-6. And if you double -5?
-10.
-10 plus -2.
-12.
-12, yeah. So generally, 4 matrix steps and you're done. Let's take this last row and change it back to an equation. You don't have to include the zeros this time. What does this say as an equation?
-6z equals -12.
-6z equals -12. No x's, no y's. So what would z equal?
2.
2. And that is your first answer. Z is 2. Now, go back up to the middle row once you got a 0. I would just use, I'd probably use this one right here. You could also use this one right here. They're the same thing. I would stick with this one though. So y minus 2z equals negative 5. And what did we just get for z?
2.
Fill that in. 2, well, negative 2 times 2 is negative 4. Which means y equals negative 1. Yep. That is your second answer. Red. Now, third answer, I would just go all the way back to the top row. 1116. Okay. What did we get for y?
Negative 1.
Negative 1. What did we get for z?
2.
2. Fill that in and see what we get. So x minus 1 plus 2 equals 6. Negative 1 plus 2 gives me positive 1, which means x would have to be 5. Yep. That is your third answer. Now, answers don't always have to come out to nice numbers, but I would say most of the examples that you're going to see on the test, you will get answers without decimals. And that, if I zoom in a little more, those are all your steps. So generally, not always, but on average, it's 4 times of writing the matrix, and then 3 calculations to get your z, your y, and then your x. There are special things that can happen, but that's pretty general. Okay, any question on that one? Okay, so last one we're going to look at, we are not going to solve it. I just want to make sure we could set it up. So you will have some kind of problem that gives you like 3 numbers like this. First thing you have to do is pick your letters. What should we use for our letters?
X, Y, and Z.
Yeah, let's use x, y, and z for the first, second, and third number. The sum of the 3 numbers is 4. How would you write that as an equation?
X plus Y plus Z equals 4.
X plus y plus z equals 4. Perfect. There's your first equation. Okay. Second equation. Right there. The first minus the second plus 5 times the third is negative 24.
X minus Y plus
First minus the second,
plus 5Z equals negative 24.
negative 24. And if we were going to solve this, this is good because you already have a 1 in the upper left. But again, we're not solving. And the third one. It says the third plus 5 times the first plus the second is 24.
So Z plus 5X
5 times the first
plus Y equals 24.
plus y equals 24. Now, we got to be careful with that last one.
Could we leave it like that, or would you want it to be
We have to make them line
X,
up.
Y, Z?
It's got to be x, y, z. So even though the equation was written that way, that's fine to do it temporarily. But what you really want is 5x plus y plus z equals 24. Now they're lined up x, y, and z. We could solve that just like you did that one. There's no difference. Same steps. Any question on figuring out the equations first? Okay. So that's it for the matrix. That's all that we do with it. Okay, solving systems.
you go back to that real quick?
Yep. So I have more examples, but I think we did plenty, because I added this one in, so that was an extra.
I'm good, thank you.
Now, there are special cases that can happen, but the ones that I give you for a 3x3 system will not be special cases. 2x2, yes, I could give you special cases, no solution, infinite solutions. But for 3x3, I'm not going to give you those. Okay, so that's the homework for tonight. I think it's 11 questions. Most of them are 2x2. Those are not all 3x3. So there are some review from yesterday. Okay, and we'll take a look at those tomorrow.